All right, section 2.4, permutations when objects are identical of Math 3201. So this section, we're going to look at more examples of permutations, but this time within our set, there are some things that are completely indistinguishable from one another. Whether that's objects that we're saying are the same, or is it letters in a word, or a series of numbers that are the same. We want to limit to something that is completely identical. So you'll never see people used in these examples, because no matter how kind of vague we be about the people, say just sorting them by gender, for example, they're still distinguishable people. You'll never see them used here for this type of problem. So here's an example where it says, think about a set of 3 marbles in which 2 of them are green and 1 of them are blue. The green marbles are identical in every way. So you should see that the set that is the first green marble, then the second green marble, then the blue marble, in that order, would be the same as the second green marble first, then the first green one, then blue. So how we've been doing these questions up till now, if you were to sort these objects, those 2 configurations are counted as 2 separate things. So we would normally say that we have 3 objects here that we are sorting. So we would use 3 factorial. But now we want to remove the repetition, so we're going to divide it by the number of ways to sort the repeating objects. So 2 repeating objects. And what that gives us is we'll sort all 3 objects and then we'll remove the repeating ones. So that's 3 factorial over 2 factorial. Like that. But, so in general, if we have any number of objects, if a set of n objects containing A of one kind that are identical and B of another kind that are identical, we can arrange the entire set in this many ways. N factorial divided by the number, the factorial, I'll say, the number of ways to arrange the repeating things. So n factorial divided by A factorial times B factorial, or if there are more repeating objects, C, D, E, etc., you can just keep sticking letters into that equation. So by dividing our n factorial here, we remove the arrangements that we're just considering to be the same. So things are only counted one time. We'll now look at a couple of examples of using this in practice.